Well, before we get started, I would like to review with you some of the conceptual schools in the history of architecture. The metabolism, as the picture on the left, focuses on the life cycle of buildings, the standardization and replaceability of building units, and so on. While the pictures on the right, represented by MVRDV, are some studios that try to maximize customization. They try to design every single space for each user of a huge building, and thus achieve the ultimate in customization. However, there seems to be an invisible barrier between these two schools. If we want to talk about assemblies and metabolism, we can't do without standardized building units, which is the opposite of the concept of customization. If we want to talk about customization, we can't do without the architect's design for each individual, which is never possible on a large-scale building. Now, with the development of society and technology, we are exposed to new technologies and information. We just want to have a try. We want to break this barrier between standardization and customization by using some of the ideas and techniques of the new age. And yes, this is our design. This project aims to redesign a campus dormitory complex. The existing dormitories have many problems, such as the function is too simple and a lot of outdoor space is wasted and so on. The uninteresting space made the students living there complain that it felt like living in a prison. Okay, by the way, it is important to note that the dormitory is unique compared to other residential buildings because a certain number of residents periodically leave and move in at the same time. To express the kernel of our project, we have to start from the beginning. This is the kernel of our project, a manifesto. The future of democratic design and growing architecture with the participation of GAN. What is GAN? It is actually a method of machine learning by having two neural networks playing against each other. There is a generative network and a discriminative network. For example, if we want to chain a master thief in a group of people, we may need some police to catch the low-level thieves. So this is actually a simple GAN. The random group of people which generates the thieves is the generative network, and the police is the discriminative network. Each epoch makes these two networks smarter, which eventually produces a master thief. For architecture, we can randomly generate many architectural plans in the site. And then we set a scoring method to select a good and reliable result from all of these to be our design. So this is the GAN kernel of our project. The building is divided into permanent spaces such as traffic courts, structural frames, etc., and non-permanent spaces such as dwelling units. And the GAN is used to optimize and customize these two parts. This is the process of optimization. Our discriminative network includes factors such as sunlight, accessibility, scale of the piazza, transport efficiency, etc. Each epoch makes the result closer to the optimal solution and re-influences the generative network to improve the overall results for the next epoch. Here are some demos of a simplified version of optimization. The actual generation process is much more complicated than this, but the main idea is the same. Once we get the optimized permanent space of the building, we have to place the non-permanent space on it. The kernel of the non-permanent space is customization. Well, how can we customize it? Every student will come to this selection screen when they enter the building. Here, you can choose the type of units you like, the public space you want, and the facilities you need. Each person is given 100 rating points and everything is decided by the residents. After this, all these opinions will be gathered into a database, which is actually the source of the discriminative network in GAN. The generative network works tirelessly to create random facade forms, each of which receives a score from the discriminative network. And then comes the result, a deeply customized result that is best for everyone. The next part is the design of living units. All the units have been thoughtfully designed, each with a different capacity and for a different student type to meet their customized needs. Also, we designed the mechanisms used to assemble these units because the building changes periodically. Every year, a quarter of the residents move out and in at the same time. So this building will change once a year. We hope to achieve such a rich and vivid space condition like this. We also noticed the growing demand and disorder of delivery parcels in dormitory areas, so we predict that the need for logistics will become as much a part of the city's infrastructure in the future as the need for water and electricity today. Therefore, we designed an attached logistics system that integrates throughout the building. And yes, everything. In this project, we provide the residents with customized living, studying, shopping, fitness, entertainment, community, and even love. People can have them all in one. Let's have a quick review. The GAN algorithm is used to generate the plan form of the building as well as the permanent space. We use GAN to achieve deep customization of the living part, creating different living units, designing the mechanics of assembling the units, all encompassing bottom piazzas and connection to surrounding sites. Finally, we get the results like this. What is the ultimate goal of our design? We think of it as a reconsider for people's dwelling in the city. It is a beautiful vision that the pleasures of living, which are neglected in the buildings in cities today, may return to our lives in the future by using advanced GAN algorithm to help us design. I would like to conclude with a quote from CIM's 1930 Manifesto in the Athens Charter. The four keys to urban planning are the four functions of the city: dwelling, work, recreation, transportation. When the city becomes the building becomes the city. Thank you.